So we just finished our first example with confidence intervals and creating one sort of more by hand. And then I showed you how you could do it with a calculator. So our next example says use the data from example one, and I like the first example, to calculate a 90% confidence interval around the population mean amount of soda. Did your interval become narrower or wider? Is that what you expect? Okay, so with our last example was we are 98% confident, right? And so with this one, it's saying, what if we said our confidence was 0.9, right? So I'm just going to copy a couple of our information here. So sample size was 12, population standard deviation was 1.55, and the sample mean was 13.3. Okay. So if I think of this, right, if I just drew a picture, so let's see, so 90%, right, maybe we would say is here. Right, so this is 90%. And if I think of where 98% would represent, right, 98% would be more of the curve, right? So maybe it's all of this now. So this is my 98%. So if I think of, creating this interval, right, this interval would be from here to here, whereas the 90% right here to here. So we should expect that the 90% interval should be smaller, right? We're not as confident, so it's going to be a little bit narrower than the 98%, which includes more of the curve. So let's see if this is true. So you can go through, you could find your margin of error. You can find your critical value and sort of, plus or minus. I did show you last time you can use your stat button, go over to tests, and go down to your Z interval and hit enter. And so we have our stats, right? We had this from last time. 1.55 is the standard deviation, 13.3, 12 is the sample size, but now it is 0.9 for our confidence level, and we'll calculate that. So the confidence level that we have now, right, and if I round it to 12.56 to 14.04. And if I compare that to the last one, right, let me write this in a different color. The 98%, right, was 12.26 to 14.34, right? You'll notice that it is a little bit wider. So what does this mean, right? So if we decrease the confidence level, right, and we keep everything else the same, that's important. We create everything else the same, but we just decrease the confidence level, it's going to decrease the width of the interval, right? So it's going to decrease the width of the interval. It'll make it a smaller interval. And so sort of the converse is true. If we said, if we went from 98 to 99%, we would see that it makes it a wider interval. So just sort of keep that in mind. And again, we're just saying that as long as everything else stays the same. So let's look at the next example. It says use the data, right, from the last example. Keep a 98% confidence level, but this time change the sample size to 50 instead of 12. Did your interval become narrower or wider? Is that what you would expect? Okay, so let me write everything down here. So again, we're saying 98% for the confidence level. Instead of 50 now, instead of 12, n is 50. Population standard deviation is still the same, and so is the sample mean. Okay, so we're going to hit our stat button again, over to tests, go down to our Z interval. Our stats the same, so you'll notice, right, we have now 50, and we have 0.98. Okay, so what happens if we increase the sample size, right? So I will write this one in blue. So 12.79 to 13.81. We'll write the one that we found right previously. as 12.26 and 14.34. All right, so let's take a look at what we see, right? So if I look at which one is narrower, the one we actually calculated is narrower, right? So you may be thinking maybe that's not what you expected, right? Narrower, this one is wider. So what happens when we increase our sample size, right? We get more value, and so we can be a little bit more precise with our estimate, right? And so what happens is we can actually narrow it. And so we're still 98% confident, but it can be a little bit narrow since I've sampled more from my population. So if we increase sample size, it will decrease the width. So decrease the width of the interval. Okay. And again, just looking, we're only really changing one thing at a time. If you change multiple things, then, you can't really compare the intervals. But if we keep the same confidence level and we just change the sample size, it will decrease the width of the interval.